Hello. Today we'll be demonstrating Iris for Health as an AI smart data fabric. We'll show the need for this. We'll also show a short demo of that and hopefully give you a better understanding for how Iris for Health can actually handle this going forward. I want to start with basically the whole idea behind AI is really becoming a corporate strategy. Um, you have AI leadership, research and development going on. You have everyone really highlighting AI and where it needs to go and how it's going to be helping companies actually product development and everything else under the sun. Um, they're really looking for ways to deploy value into the workflows that the customers or their employees or their patients or anyone else are having to deal with. And they're starting to try to identify the required data from the corporate silos because data still is sort of siloed out. You have your healthcare data, you have your payment data, you have all sorts of other ancillary data that can probably be fit into an AI model, but it tends to be somewhat siloed out there. Um, and there are also some roadblocks that they're encountering in delivering real AI value because in order to have good AI value, you also need to have good data behind it. Because if you can't train your models, your AI models or anything else with valid data, then you're not going to get valid intelligence out of it. Iris or Health really helps that way in a few places. One of the things that they're sort of looking at in the AI world is that, especially in healthcare, they need some sort of data model or a healthcare data model where they can pull all this information in so that they can sort of build it once and populate that data model and then allow that data to be used in the AI space itself for the training and also for how it's working with all the information that's coming into it, even real time. And Fire is really emerging as a standard there. Um, Also, the other difficulty is really obtaining large quantities of bulk training data. Um, so once you've decided on your model, you also have to say, okay, well, how can I actually populate that model with enough data so that I can actually train my models successfully? Train the AI agents and everything else to handle things with proprietary or information that's very specific for what you're trying to do. And then you also need real-time triggers for fresh analysis on the MI and the AI. And Iris for Health really does handle all of that. There's a number of building blocks for an AI smart data fabric. I think InterSystems and Iris for Health really differ in a number of different ways. A lot of external tools, the processing is really done externally and has to be all brought together. We try to make a model where the processing is very close to the data, which allows for a lot of performance improvements and scale, um, which is very important. And then the data fabric of all the native data is there as well. I mean, you can't, in today's day and age, you can't just take a certain silo of data and say, okay, let's make AI that works for all the different workflows that we need in there. You really need a repository that's going to handle all of that. Fire is certainly handling all the healthcare type data, but then you can also, when you have a data fabric, you can not only use Fire, but you can have other inputs, maybe SQL tables or anything else that you can pull into it. And Iris Health has always been a master at orchestration integration as far as where data comes from and where it goes to. And there's also a very extensible transformation library, which allows you to pull in a lot of different, especially healthcare, but also more generic, SQL technology type transformations that need to happen as well. There's also very strong support now for the Python language and libraries. So a lot of Python libraries that are out there that work in the AI world already, you can actually import and work with those directly. And there's minimal data duplication depending on how you des design your data fabric itself. A data fabric could be, hey, I'm grabbing the information as I need it, or in this case, what we're proposing is that you use the integration and orchestration capabilities of Iris for Health to pull that data into a Fire repository, also built on our product because we have some advantages as far as performance and speed. Very fast dollar everything performance and also very fast bulk Fire allows you to really hydrate uh, your AI models and the data that they're going to be trained on very efficiently. And then, of course, we have this sort of multimodal or multimodal data projection. in Fire, SQL, XML, JSON, vector and column storage, and indexing. There's just a lot of different ways that you can store the data and natively within Iris for Health, where in other places you probably have to have a separate product to store the different types of data that you're actually dealing with. An example of sort of a Iris for Health AI clinical data flow. This uses a lot of the tools that we've had before, but if you look at the start, you have first of all, you're going to have a lot of real-time data feeds of different information coming into the system. When those feeds come in, whether that's SDA or CDA or whatever, we can basically then transform those in most cases automatically into a canonical data format that we have internally to Iris for Health called SDA. That SDA format already has pre-built transformations that allow you to go from that standard into Fire, and then from the Fire, and we can put that directly into the Fire repository. A couple important things about this is that we're not actually storing the data in the SDA format. That's sort of it's a intermediary format that doesn't have to be persisted. And so we can pull that information in. We can then do a transformation on that directly into Fire resources and then put those into the Fire repository itself. We also have a lot of other capabilities within that with filtering and different things that you might want to do on the data itself. And then that data can then be exposed directly out to AI or machine learning or other things. Then on top of that, you could build a Fire SQL projection on top of that with our product as well, which allows you to basically say, okay, on this resource or these couple resources, I want to grab these fields, or these different pieces of that and create a table with those columns and a row for each different patient or each different uh, component that you're actually looking at, which can be very powerful. That can also allow you to pull that out as tables, or allow you to use that with different BI tools. So you can do a lot of different reporting and analysis of things like that, even outside of the AI world. Another normal way, or another way that we could see this being used, is that you would have a certain uh, request for a certain information about a certain patient. And that request would basically go back to an EMR and say, okay, well, I want the CCDA for this. So we're not storing anything at this point. That CCDA can come in, and we then take it right through our normal feeds where it transforms it into SDA, and then that SDA, again, not stored anywhere, is then transformed into Fire, where we're finally depositing that or inserting that into our Fire repository for later analysis. So there's a lot of different ways that we can get to this. There's a lot of different ways that you can configure this. But what I want to do now is do a very short demo of a smart data fabric as we have it working. So let me get out of here real quick. And we'll go over to our demo. So one of the demos I showed before was the ability to bring in a multiple different data types as we're coming in. So in this case, we have services that have underlying, automatic capabilities to handle CDA or CSV files or HL7 or any type of XML that's coming in that we can handle sort of natively with adapters and things like that, or transformations that we can do. That then comes into what we call a legacy to SDA process. And that process basically says, okay, let's take a look at everything that's in here. I think I have it open right here. Let me take a look at all these different types of things that are coming in. And then I'm doing a lot of the same thing. I'm basically doing a switch on, what I'm doing here, whether it's an HL7 message, a CDA XML message, a record map, which is basically a definition of sort of a delimited file that's coming in, or just a custom XML message. And I do sort of the same things. I figure out which type they are. This is just a trace. I then do an assignment that basically says transform it into SDA and get back my SDA as the return value from that. So we have one for HL7, we have another one for CDA, we have another one for the CSV. All these cases are really just a transform that's being handled underneath the scenes themselves. And some of it is pre-built transformations that can happen, like the CDA to SDA. The HL7 to SDA actually has that as well. These are extensible, which means that if we don't have everything that you want to do in there, you can extend both sides of this, both the mappings and also the data structure itself, which is inherently um, persistent between different upgrades and everything else on that. So it's upgrade safe. And then we basically package up whatever we got back from there as a stream, and then we call a pre-built process, which basically knows how to take SDA and change it into fire. So we can call the different the target that we want on there and get it. And if you want to, if we look at the data flow of this, so let's take a look at any messages that came in here. So here's a message that came in that basically came from the CDA input. So let's take a look at this one as a transform. In this case, I have a stream container that came in. That stream container just has an XML file. I believe I do a little bit of a, here's the actual CDA that comes in. So this is, not the most readable format in the world, but we already have sort of a way to automatically bring that in. That goes into the SDA to fire process. The SDA to fire process basically says, well, here's my SDA, go ahead and change it into fire. And that's what it comes out of the SDA to fire process, is this fire bundle. That fire bundle then is posted into our fire repository in a very nice way. And it comes back as sort of, here's all the different things that came back with what happened in it. And we get a successful insert. So that's just one method that we came through of sort of following one of these things in. If we come back into here, most of this is CDA that we've been doing because we've been doing some testing on that. But HL7 or anything else works the same type of way. So I can go into here. And I can see that I did have one HL7 message come through also. Typically this would be the opposite. You'd have tons of things. So I can have a full featured HL7 message come in. I can then go through and create a fire bundle out of that automatically with the transformations that are built in. And then at the end, that is now put into my repository as well. The other scenario we have is that I have a patient record that I want to do. Right? So I have a patient record collector. It basically, in this scenario, what I'm doing is I'm passing in a, I'm passing in a MRN for a particular patient that I want to do. That MRN basically says, okay, well, let's see if we have that in our fire repository already. So it basically does a patient get for our fire repository with this identifier. And it does the request out and it gets back, okay, yeah, I do have this patient. Here it is. Here's the response back that it comes through. I can also go out to, I can also do a request once I know what that fire resource ID is. I can also go out and say, okay, now give me everything about that patient, not just the patient information. And then when I get that back, I actually get a bundle of like every single resource that's associated with this patient. In this case, it's somewhat small because we have a test system, but that could be, hundreds of different resources depending on how much history is in there. And then at the end, I can also do things like delete stuff out or, do other types of processing that I need to within my fire repository itself. This patient collector then does a few things. It does some things like flipping a bundle from a search to a transaction so that I can put it into things. It does maybe a patient delete. Those are some of the things we're doing. And then this could also be a request sender itself. So I might be sending this out to an external system to grab some of this data. So it's not just limited to ours. You can certainly build this same data fabric with external fire repositories as well. We just feel that Iris for Health and the fire repository we have built into that is actually a lot more performant. And that is sort of an example of the data flow that I showed in the beforehand. Hopefully you guys get a good idea of what Iris for Health and this AI data fabric can do for you. And thank you much. Bye.